We've been in data science and machine learning and artificial intelligence for quite some time now. We've seen lots of students around the world become successful in this space and go from zero to hero. And we really, really want the same success for you. And that's why we've put this course together to give you a roadmap of how to become successful in data science. And in this quick tutorial, we're just going to look at the structure of the course so you can understand what it's all about and how to navigate it better. So let's have a look. In this course, we'll have 5 sections. In section 1, we're going to discuss the ultimate data science guide. Here, we will give you a roadmap of how to go about getting into data science. So if you're just starting out, if this is your first time learning about data science, so if you've only seen little bits and pieces of data science, we will help you have a structured way, a structured path through data science, so you know exactly what to go through and how much time to spend on each topic so that you can get to the end result in the most efficient way possible and learn everything you need to know to actually start applying data science in your work. In section 2, we're going to give you a taste of data science with a specific tool called Tableau. We'll give you a taste of a specific type of data science, which is called visualization for data mining. And this is specifically intended for you to get a feel for what it's like to be a data scientist. We're actually going to solve a real world case study, a real world challenge, and you will see what goes into being a data scientist, what kind of thinking, mindsets, skill sets are required, so you can understand for yourself if this is indeed the right profession and if indeed you're interested in pursuing this further. And then in section 3, we'll give you another taste for data science, but this time with a different tool. We'll give you a taste for data science with Python. And Adlan here will walk you through applying 2 different machine learning algorithms to 2 different data science problems. And I love this section because both these sections actually, because they're a testament to how quickly you can get started into data science. If you follow along with this course, within a few hours, you'll be solving some very interesting real-world challenges with some quite advanced techniques. For example, in section 3, we'll be applying some one machine learning algorithm to solve an energy problem and another machine learning algorithm to solve a health problem that can really impact people's lives and impact different decisions that industries make. Next, in section 4, we will talk about data science with the cloud, and we'll show you what this term is all about, why it's important. And this is just a quick overview, because as a data scientist, you are likely to encounter the cloud, and some of your work will be in the cloud, and therefore we want you to be prepared for what to expect when this does come up in your career down the track. And finally, in section 5, we'll have a course conclusion where we'll run through everything that we've talked about to make sure that we have a good recap and that you're ready to get on your way to becoming a successful data scientist. So all in all, a very exciting course. We're super pumped to get started. We know what it takes to become a data scientist, and our statement here is that you can become a data scientist in 6 weeks. You can become a starting data scientist. We're not promising that you can become a super successful best data scientist in the world. No, but you can become a data scientist that can add value to businesses, that can apply machine learning, visualization, understand statistical concepts, and use Python and other programming languages and apply machine learning concepts within 6 weeks. And to prove that, we've got a specific timeline set out for you, a specific path with a timeline attached to it. So we're going to go through it now, and we'll show you exactly what you need to study and in what order and how much time you need to spend on each topic in order to get there. You ready? Let's dive straight into it. All right, so you start here on day 0. And the first thing that we suggest looking at is statistics. And all of these topics that we're going to cover off here, there's going to be 10 steps to get to the finish. We're going to talk about them in more detail in this section of the course, and you will get to know them a bit better. So don't worry if you feel a bit like you don't really understand why something is important or why something is necessary, what it constitutes. That's okay, because first of all, we'll talk about it in this section of the course, and then moreover, we will cover off this whole map again in the conclusion of the course, just to reiterate everything once you have a different perspective, once you know what these topics are about. So statistics, we suggest spending 6 days on statistics. And the reason, so we're going to mention, in this tutorial, we're going to mention the why. The reason why we think these things are important. And the reason, the why for statistics is to avoid costly mistakes. I'm a firm believer that you don't really need to know all the statistics in the world to be a successful data scientist, but you do need a core foundation in order to avoid mistakes and in order to avoid misrepresenting results and misinterpreting insights. And in this course, we'll tell you exactly what statistics to focus on. It should be sufficient for you to be able to grasp those concepts in 6 days. Next step is to learn the data science process. And don't worry, we've got you covered here. We will actually walk through the data science process in one of the tutorials in this course. So that part we've got covered for you, and you can always reference back to it if you need a refresher. It's got 5 steps, and the data science process is the process that pretty much any data science project goes through. And it's important to kind of distinguish what we're talking about here is your roadmap to becoming a data scientist, whereas the data science process is the process a data science project goes through. It contains 5 steps, and it's good to be aware of it so that you know the bigger picture. But once again, we've got you covered on this, and so let's proceed further. The next step is visualization. Learning about visualization and picking a tool and learning how to apply that tool to create successful and insightful visualization, it should be sufficient. 10 days should be sufficient to get you going on the way. There are some very powerful and yet simple to use tools that allow drag and drop interface. Some examples are Tableau, ClickView, and Power BI. So those are just 3 tools I can name off the top of my head that it takes like 2 or 3 days to get your head around and be able to use. And in 10 days, you can create, by then you can create like 5 very powerful visualizations, and you will know 60% of that tool. You will know how to use it in, how to leverage its power for your work. So we're allocating 10 days to it so that you can get to know it and actually practice. In that time, we actually expect that you fulfill the next checkpoint. So these orange or these brown boxes identify checkpoints, and we expect that, or we suggest in those 10 days you attempt your first data science project. So what we're saying here is that those 10 days are enough to learn visualization and practice some follow along kind of projects with instructors, whether you're taking these courses online, in person, reading books, or watching videos. But what we're saying with the checkpoint is like try to attempt your first data science project using visualization techniques that you learn in those 10 days, and you will see that it is actually not as difficult as you think. You might not be able to complete the project end to end, not yet, but you'll already be able to get some insights and get some valuable information from the data. Next, from there, the next step is databases. So the why behind databases is so that you expand your reach of data, so that you can have access to more data. So up until this point, you're probably looking at data, well, in this process, so in statistics and visualization, you will be probably looking at data in CSV files or Excel files, whereas if you learn the basics of SQL databases, you'll be able to get more data, access to more data, and therefore perform more analytics. And again, we're allocating 5 days to this simply because to get the basics of working with databases, 5 days is well more than enough to understand simple concepts like a select statement in SQL. That takes just a couple of days, and in 5 days you should be able to know the basics of how to extract some data from a database. The next step in our path is statistical learning. The reason why we're allocating only 2 days to statistical learning is not because it's a simple concept, but because we want to make sure that you don't get bogged down in statistical learning or you don't get too carried away with it. Those are 2 extremes that are going to create hurdles for you progressing to becoming a data scientist. In order to be a data scientist, you don't really need to know all the ins and outs of every single algorithm. That you might need if you want to do research in the space of data science. But some basic statistical learning principles are going to be sufficient in order to just give you an example of what it's all about. So the why here is in order to get a feel for what statistical learning is, and to see that if you want to delve deeper into a certain machine learning algorithm, you can, because of statistical learning. And then finally, next step, and probably the largest step in our journey, is machine learning. We're allocating 12 days to this because understanding how to apply machine learning algorithms and when to apply which one is very important. It is one of the most used concepts. In fact, it is the most used concept in the whole data science. You will see that a lot of business problems, a lot of industry problems, a lot of health problems, a lot of all sorts of types of problems are actually solved using machine learning. And that's why it's such an important concept and such an important space. And the idea here is that you take those 12 days to learn several algorithms, between 3 and 5 different core machine learning algorithms that you would look into, something from regression, something from classification, something from clustering. And those are just branches of machine learning. Each one of them has like at least 3 to 7 different algorithms. So, but if you learn at least one algorithm from every single one of those branches, one from regression, one from clustering, one from classification, and maybe 1 or 2 other ones, just get to practice them. If you spend 2 days per algorithm, that should be totally enough to give you an understanding of, first of all, that you can do it, and second, the types of problems that they solve. So that in the future, when you come across a problem, you know, oh, I've seen this somewhere, or it feels like I need to use this algorithm, and I'm going to go do that. So that's machine learning. After that, we've got another checkpoint, attempt an advanced data science project. In fact, that checkpoint is actually included in those 12 days. So as you spend the 12 days learning 3 to 5 different algorithms, give it a shot to take on an advanced data science challenge, and you'll be surprised at how far you can progress already. Then we allocate 5 days to learning more about Python. So in this case, we're suggesting to apply machine learning using Python, and therefore learning more about Python is going to help you speed up your process. So the how behind learning, or the why behind learning Python, is to increase the agility with which you can solve these machine learning challenges. 5 days should be enough to learn the basic principles of Python and get enough hands-on practice so that you're more comfortable using Python. And finally, at the end of our journey, we're allocating 2 days to deep learning. Again, it's not because it's a simple concept. It's rather to get a feel for deep learning, to understand what is possible in the world of deep learning, what other opportunities it opens up. So you always know that there's this alternative to your visual analytics and to your machine learning analytics. There's something even more advanced, which is called deep learning. And then one day when you do decide to dive into it, you know that it's there, and you know where approximately in which direction you need to go. So it's good to have that overview. And so after that, ta-da, 42 days, you made it. If you follow this process and you diligently put in the hours every single one of these days that we specified here, at the end, by day 42, you will be ready to go out there and to tell the world that a new data scientist has arrived, and you can go on Kaggle and start looking at different competitions where you can participate. You can go on Upwork and create your data science profile and say that you're a starting out data scientist, and start bidding for jobs and getting hands-on experience that way. And maybe if you're starting out on your own, then you can approach your first client. It might be scary, but based on all the work you've done and all the hours that you've put in, by this stage, you are ready to start into the real world. Visualization for data mining. So we have a whole section on where you can get to play around with Tableau and solve a real world challenge step by step together with us. And also same thing for machine learning. We have a whole section where you'll actually solve 2 challenges together with us in machine learning using Python. So very excited about this course. We hope you're excited about this journey, as excited as we are. We've just come up with this concept and we're just introducing it to the world. So you are going to be our first subjects that are going to go through this, and we're very confident that if you follow this rigorously, if you take this course to the end and you actually get a feel for what data science is all about, and you decide that it is what you want, it is what you're after, then if you follow this map and you put in the hours and all of these days and you use credible sources for your knowledge, for your practice, then we're very confident that by day 42, you'll be out there and ready to take on data science challenges. And so the question is, why are we starting our very first step into the world of data science with statistics? And moreover, it'll be even more confusing if you've already taken any of our other courses, because you've probably heard me say there that you don't need to know statistics to be a data scientist. Isn't that counterintuitive? Isn't that contradictory, even that on one hand, I'm saying that we don't need to know statistics to be a data scientist. On the other hand, the first step in our journey is statistics. Well, the answer is quite simple. The thing is that historically it so happened that people have this attachment to the thought that data science and statistics are similar or even the same thing. And some people think of data scientists as statisticians, some think of data scientists as actuaries. And while historically, indeed, a big component of data science came from the world of statistics, with time data science has evolved so much and has taken on so many things from different industries and from different professions that it is very, very different now. And you cannot still have that logic. That logic no longer applies. There are parts of data science where indeed you will need statistics, like if you're doing research in machine learning, or if you're doing quite advanced things in the space of health, for instance. But there are lots of other component or other types of data science, like visual analytics or visual data mining, or maybe just applicable deep learning in application rather than going in depth into deep learning. There's lots of areas of data science where you can do without very in-depth statistical knowledge. Now, having said that, I really also need to point out that statistics or the core fundamentals of statistics are going to be helpful for a starting data scientist because they will prevent a lot of mistakes. So that's why we're putting statistics as the first step in our guide, because if you get the grips with just the basic, easy principles of statistics, like just having that mindset of, like, for instance, what is a statistical significant result? What isn't? Things like that are indeed important. That's why we've put it here. So let's have a look at the list and it'll be a bit clearer from there. So statistics fundamentals, the 8 things we feel or we think are important for a data scientist to know in statistics. Number 1 is distributions, and it has some subcategories here: normal distribution, standard deviation, mean, median, mode, types of distributions. Number 2 is the central limit theorem. Number 3 is hypothesis testing, which has z-score and t-test, which we've identified as important. Number 4 is statistical significance and p-values. Number 5 is confidence intervals. 6 is A/B testing, and 7, Pareto principle, or the 80-20 rule. It's also known as that. And number 8 is law of large numbers. That's my favorite one. So those are 8 things that we think are important in data science. Not advanced statistical data science, but just general data science in terms of statistics. And now I want to apply what I said before, that even out of these, not everything is absolutely necessary to get started. Like, you can get really stuck trying to learn all of these and master them. It'll take you a couple of months or, at least a couple of weeks to get your head around these properly and be using them efficiently, without having to, reference materials and things like that. So even out of these, we're going to point out the top 3 that you really should look into before proceeding with the next step in your data science guide. And the top 3, in our opinion, are distributions, and just the parts that you need to know what a normal distribution is, you need to know what a standard deviation is, and you need to be able to tell the mean, median, mode from each other, especially when there's a skewness in the distribution. Then you need to know about statistical significance and p-values. It's very important because it, again, helps prevent reporting on things that are not statistically significant and therefore driving bad business decisions or bad insights. And finally, A/B testing. It is important in many industries, whether it's marketing, online marketing, or whether it's the health industry and so on. And from there, it builds the right mindset for comparing side by side different results. So that's also important. And all of these are quite simple. You can really get the grips of these three things in a couple of days. You can understand them. And the main point is not to become an expert, but to build the right mindset around them. And they will help you going forward. It'll just help you think differently about all of the data that you're looking at, about all of the analytics, about all of the insights. And that's what we mean when we say that statistics is a good first step. It's not a good first step if you're going to dive into it and spend 5 months learning it. It's a good first step if you're going to spend a couple of days just to refresh your knowledge if you've known these, if you knew these things back at uni or at high school, or to learn them afresh if you didn't know them. And yeah, I didn't even point out law of large numbers, even though it's my my favorite out of all of them, because you can still get by even without knowing that. So there we go. That's the world of statistics, and there's a list for you to look into. And depending on how deep you want to go, you can look into more or less points out of there. Well, at this stage, it's important to take a step back and have a bigger picture view of what is going on in the space of data science, or how it all fits in to the end-to-end process when you're doing a project. So basically what this whole concept, this data science process describes, is that in any data science project, there will be phases, there will be steps that you need to perform, or stages of that process or of that project's life cycle. And if you understand these phases well, if you understand what they're all about, then all of the different components of data science, whether it's statistics or visualization, machine learning, all of these will fit in very well into this process, and you'll understand why exactly you need to learn them, and also at which point in time to apply what. So let's go through this process step by step. The first step is very important, and it's often missed by data scientists and even by resources that you'll find online. They often don't mention it. So the first step is called identify the question. This is the stage where you need to spend some time to consciously go and talk to stakeholders of your project and ask them what exactly do they want from this project? What exactly are they after? What are the questions they're trying to answer? And what are the questions they're not trying to answer? And at the end of the day, you need to get their agreement to the scope of the project in writing in order to safeguard yourself from scope creep down the line. If you commit to a certain project, you don't want that project to explode to 10 times the size just because people want more and more and more answers and more insights. And that's why this step is very important. First, you want to identify the question so you know exactly what you're looking for, rather than just diving straight into it, into the data without having an idea of what you're after. And at the same time, you want others to agree to that scope. And also, I'm going to point out how long approximately I think these stages should take, and that's mostly based on my experience and experience of other data scientists. So if you're doing a data science project end to end, then this first stage, identify the question, should probably take about 10% of your time. Next is another important stage, which is called prepare the data. You need to take the data, get it from wherever it is stored, ask the client if you're working as a consultant, or find it internally and talk to the right person in the right department, get it, clean it, prepare it for analysis, check that it's complete, look out for anomalies, fix them, and then of course do some Q&A on the data. And this part of the data science process is actually one of the toughest parts and one of the most tedious, and some data scientists really don't enjoy going through these steps, but at the same time they're very, very necessary, and it takes up 70% of the data science project. That's why, for instance, knowing how to work with databases is an important, very important skill. And also statistics is important because you can look at the distributions of your data, understand, know how to deal with anomalies and things like that. So data preparation is a very important stage. Also, visual data mining can help you out here as well. So that's the first two stages. Next stage is called analyze the data. This is the fun stuff. This is where you get to apply machine learning. Again, you can apply visual data mining, you build models, you run text analytics, and lots of other really cool and fun things. And the best part is if you've done the data preparation well, and you don't have to go back and fix the data all the time. If everything is set in the first two stages, and you know what you're looking for, you've identified the question, then analyzing the data shouldn't take that long either. It takes about another 10% of your time. So funnily enough, what the whole hype of data science is about, the analytics part, is actually only 10% of the time you spend there. That number might vary, some might give it up to 20 or more, but again, if you've done everything before correctly, this should be a piece of cake. It should be very, very quick compared to the data preparation part. But at the same time, much more fun. Next, fourth stage is visualizing the data. And that is another very important part. One thing is to find the insights. Another thing is to present the insights in a more friendly way, in a more approachable way for anybody. And that's where visualization skills come into play. And this is a different type of visualization from the ones that we've mentioned before. So you have visualization for data mining, which is helpful in stages 2 and 3, where you're exploring the data, you're trying to get insights. This type of visualization in part 4 is the visualization where you actually build the image or the dashboard or the storyline and things like that. So in order to communicate your insights better. And this takes how much time? Well, it takes about another 10% of the time. And so by now you're probably wondering, if you've been following along, we've already taken up 10 plus 70 plus 10 plus 10. We've taken up all 100% of the time. Where are we going to find more time for the last part? And the last part, first let's find out what it's called. It's called present your findings. This is the part where you need to communicate your results to your audience, to communicate your results to the stakeholders, the CEO, the manager, the board of directors, the customers, the clients, whoever was the person that asked you or the team that asked you to work on this. You need to explain the insights and what they mean, what actions they might imply or they might recommend for the business, what actions those insights might recommend for the business. You need to explain that. And you need to explain in a very approachable manner and in a way, to quote our mission at Super Data Science, you need to make the complex simple for them. And it might look like this takes up 0% of the time. No, it actually takes up 80% of the time. Another 80%. And this is a very representative diagram in terms of percentage of time. Very representative in the sense that how data scientists think about it. They think, okay, well, I'll get the project done, everything's finished, I visualize the data, okay, 100% of the work's done. And that's where the 80% unexpectedly creeps up. And I actually had a podcast on the Super Data Science show with Yao Tan, I think it was episode 10. He was a very dear colleague of mine back in the day, and I considered him my mentor when we worked together. And we actually discussed this, and since then I call this phenomenon the 80-20-80 rule of Yao. The reason for that is that the first two parts, these two parts, they take up 80%, then these two parts, the preparation basically takes up 80%, the analysis and visualization takes 20%, and that's what usually data scientists refer to when they say 80-20, that this takes 80%, this takes 20%. But if you take into account how long it takes to present your findings, that's an additional 80% that you were not expecting to spend. So budget that in. So however long this part will take you, an extra 80% you need to spend on figuring out how to communicate your insights and then actually communicating them and following through with, helping people follow through with your findings and implementing them. So there you go. That's the life cycle of a data science project, or otherwise known as the data science process. You might find different versions of this online. This version is our version, what we've come to over the years of experience and dealing with data science.
In order to guide you in this fantastic but huge world, well, I'm going to walk you through the structure of our course, simply because we know that was the most important thing to work on, and we actually worked several months to find that ultimate structure. And so that's why in front of me I have the whole structure of our course, Machine Learning A to Z. And this is not to tell you to take the course. This has nothing to do with this. Feel free to take our course or any other course. The Machine Learning course by Andrew Ng is also amazing, and you have some other courses on machine learning on the internet that are also great. I'm just taking here the structure of our course because this is for us the best path you can take in your machine learning journey. So here we go. Let's start with the first step, part 1, data preprocessing. Data preprocessing should be the first step of your machine learning journey. Why is that? It's because without data preprocessing, you cannot apply your machine learning models. Your machine learning models need a certain cleaned format of their input to be able to return the output. Because so far in 2018, machine learning works on the input and output process. You feed your machine learning model with some input and it will return some output. Whether it is something you want to predict, that's supervised machine learning, or something you don't even know you wanted to identify, which is unsupervised machine learning. So data preprocessing is essential, and as you can see, we tell you everything. We give you the essential steps, how to import the data set, how to handle missing data, how to smash categorical data, splitting the data set into the training set to train your model and the test set to test your model, feature scaling to put all the variables onto the same scale, and we give you, in the end, a template so that you can save a lot of time on data preprocessing. So that's the first step. Don't forget it, because the more you work on it, the more you handle it, the better your future machine learning journey will be. And then, speaking of this machine learning journey, there it goes, because the next step is regression. That's the part 2 of our machine learning course, and in this part, we tackle all the essential regression models. So what is regression? Regression is when you want to predict a continuous real number, like a salary, or a temperature, or an energy output. You will see that in the Python section, we will solve a regression problem and we will have to predict some energy output. Well, that's regression, and you have many regression models. We introduce you to the most useful ones. Simple linear regression, when you have one feature to predict something. Multiple linear regression, where you have several features to predict something. Polynomial regression, when the relationships between what you want to predict and the predictors is not linear. Then support vector regression, another regression model based on SVM, super vector machines, decision tree regression, and random forest regression. And in the end, you need to know how to evaluate the performance of your regression models, and we give you the right tools for that, the right metrics, which are the mean squared error, the R squared, and the adjusted R squared. And then we also provide some regularization methods in order to avoid overfitting. Alright, so that's the second step, regression, and then what comes next is step 3, classification. So classification is this time about predicting a category, or what we call a class. So that's a discrete category you want to predict. For example, the winner of a football game, or the next president of the United States, or the winner of the Super Bowl, or if yes or no, your customer will buy your next product. So very useful, and actually this can be applicable to many business problems, whether it is in sales or marketing or any other business purpose. And again, for classification, you have several classification models. The most classic one, but yet powerful one, is logistic regression. Then you have the KNNs, then you have the support vector machine, then you have the kernel SVM for nonlinear problems, then same naive Bayes for nonlinear problems, and also when they have a probabilistic approach, then decision tree classification, random forest classification, and again we give you some metrics to evaluate the performance of your classification models. And that's a lot of models, but no worries, this is because all the data science problems don't have the same best model to solve them, and that's why we give you several machine learning models and we explain in which situation you should use one or the other. But even if that's still too much for you, well, you'll see in this course, in the section on Python, I'll give you the solution when you actually don't know which model to choose for your problem. You know, when there is no prior analysis of the data set, the problem, and when you don't know which model to choose. Well, there is actually one best option by default, which is the model we will implement in the Python section. So you'll see what it is. I will let you find out the surprise. All right, so that's next step. And then fourth step, part 4, clustering. So clustering is this time unsupervised machine learning. It's when you actually don't know what to predict. So it can be, for example, identifying some segments of customers which will respond to a certain concern you're having. But you could also apply clustering for MRI scans, to identify tumors in the brain. So clustering has many applications, and it has two major models, which are k-means, the most popular one, and hierarchical clustering. So feel free to check them out. They're a classic in data science. Then next step is association rule learning. Association rule learning allows you to predict what the customers will buy, knowing what they bought before. So, for example, you see on Amazon or other online stores, people who bought also bought. Well, that is thanks to association rule learning, and it has two major models, a priori and éclat. But I highly recommend to at least master a priori. It can be very useful. Then the next step is reinforcement learning. So here, you notice we are starting the specialized branches of machine learning, and that includes even association rule learning. But here, reinforcement learning is even more specialized. And for those of you who aren't intimidated by artificial intelligence and want to get into it, well, you must start with reinforcement learning. I will highlight this in 2 or 3 tutorials when I introduce you to artificial intelligence. But reinforcement learning is the foundation of artificial intelligence. Here, we cover 2 powerful reinforcement learning models that can be extremely useful for business purposes. For example, to choose the right ad to show to the user so that they will click more to buy your product. So we do this with 2 reinforcement learning models, upper confidence bound and Thompson sampling. So maybe start with this, and if you're interested in that machine learning branch, definitely continue with artificial intelligence. Then, next step, another specialized branch of machine learning, natural language processing. So here actually it's interesting because natural language processing is just combining the classification branch of machine learning, which is part 2, with text and voice, to apply machine learning classification models on text and voice, to predict, for example, if some reviews are positive or negative, or to predict if some Twitter tweets are kind or mean, or if they should be reported, whatever you want. And it can even be predicting the genre of a book. The input of your NLP model can even be a book, and you have to predict the genre of the book, or it can be some newspaper articles for which you have to predict the subject, for example. So that's very powerful, and that's widely used in modern applications today, like chatbots or assistants or any other products that integrate text or voice. Then next step, deep learning. You probably have heard of deep learning. This is one of the most powerful branch of machine learning, and we introduce here 2 neural networks, and we call them artificial neural networks as opposed to the real neural networks inside the human brains, and we apply them for a business problem, which is to predict which customers are more likely to leave a bank, and that problem is called customer churn. Then we also have the convolutional neural networks, which are like adding eyes to your previous artificial neural networks, because basically with these convolutional layers, the model can really look at images and, for example, predict what's inside them, detect some objects, or recognize some features. So these are very powerful, and these are widely used today in deep learning. And of course, if you're interested in deep learning, Kirill will introduce you to deep learning in the next tutorial to say more about this. And then the next step is dimensionality reduction. Once you master all the previous branches of machine learning, you will need to push your analysis further by considering some even more powerful tools to solve your machine learning problems. And one of them is dimensionality reduction, because today we're working with some huger and huger amounts of data, and sometimes we work with terabytes of data, and for this you need some techniques to reduce the dimensionality of your dataset. Dimensionality reduction can be essential for this kind of dataset and to improve even more your models. And so we introduce you to the most powerful dimensionality reduction techniques, principal component analysis, linear discriminant analysis, and kernel PCA in case the data relationships inside your data are not linear. Alright, and then final step, part 10, model selection and boosting. Actually today, we say that there are two most powerful machine learning models. These are the deep learning models and XGBoost. And that's why right here we introduce you to this gradient boosting model. It is a gradient boosting model for you to have this model in your toolkit. And also we have this model selection section because most of the time you have several options and you actually don't know which one is best, but that's okay because there are some what we call model selection techniques which can help you find this best model. And it helps you find this best model by applying k-fold cross-validation, which is the most relevant way of evaluating the performance of your model. But we combine everything in what we call a pipeline. We combine k-fold cross-validation to what we call grid search to find the best hyperparameters that will lead to the best accuracy or other performance metric measured by this k-fold cross-validation technique, which, I'll say it again, is the most relevant way to measure the performance of your model. So these are essential to know in data science, but that's of course to be applied after you build your machine learning models. So that's why it's in part 10, the last step, and that's the end of the journey.
Here are a couple of examples of deep learning, types of deep learning. We're going to look at 6. They're broken down into 2 categories: supervised deep learning and unsupervised. Supervised deep learning is when we have training data when we know the answer, and then we train the algorithm there, and then we can apply it in the future to new data and then figure out the answer there. Unsupervised is when we don't know what we're actually looking for, when we want to, kind of like in clustering, we want to apply the algorithm so it tells us the answers even though we don't really have the answers even in the past already for ourselves. So let's have a look. I've got some interesting animations prepared. Artificial neural networks, convolutional neural networks, and recurrent neural networks. So those are the 3 core types of deep learning, of supervised deep learning. Artificial neural networks are the base ones that you will need to know in order to know any other type of deep learning. Convolutional neural networks usually deal with images and image recognition, and recurrent neural networks usually deal with memory retention, so assessing sequences. So when you have, for instance, in language translation, you would apply a recurrent neural network, a specific type called an LSTM, long short-term memory network. And so here are some examples. The top ANNs, or those are the short names: ANN, CNN, RNN. ANNs are used for regression and classification, CNNs are used for computer vision, and RNNs are used for time series analysis. Unsupervised deep learning. All right, fire. We've got self-organizing maps, deep Boltzmann machines, and autoencoders. Self-organizing maps are perhaps the easiest type of deep learning, and they are used for feature detection. Deep Boltzmann machines are probably one of the most difficult types of deep learning, and they're not actually used in practice because they've been proven extremely computational heavy. Theoretically, they're very interesting and they have merit, but for now in practice, they're not really used. Autoencoders are a interesting type of unsupervised deep learning, and they're used for recommender systems in practice. So let's have a look. Here are some examples: feature detection, recommendation systems. So there we go. That's a quick overview of deep learning. Of course, this world is much richer and broader than what we just discussed here. And if you're interested to dive in, there are multiple resources. For instance, this specific structure is the one we believe in, and that's why we've structured our course on deep learning in this specific order. We've got the 6 parts to it. At the same time, there are other resources which you can find on any specific type of these neural networks, whether it's ANNs or CNNs or RNNs.
This first application of deep learning, computer vision. So, what should I start by saying? Well, this is an introduction to data science course, so of course the first thing I'm going to tell you is the first step, if by any chance you're interested in going into that field. And the first step is to start with a computer vision model that is even not based on deep learning, and that is OpenCV, that is the hard cascade detectors. So you probably have heard of this amazing computer vision library which is called OpenCV, but I'm telling you, the OpenCV library is far from being the best computer vision models used today. But it's good to start with this because this is the simplest model, it's very easy to understand, and this will warm you up for the real deal that is deep learning. So start with OpenCV, you have a lot of documentation online, you have amazing courses on the internet, we have a deep learning and computer vision course that introduces you to OpenCV, and actually we build a model based on OpenCV to recognize eyes, noses, and mouth, and even a smile. We make a smile detector with OpenCV. So start with this, and then once you're ready to take it to the next level, well, jump into deep learning and computer vision. And so now let's talk about this. What is deep learning combined to computer vision? Well, I have to mention three models, three major and powerful deep computer vision models. The first one is the SSD, single shot multi-box detector. This is one of my favorites and this is one of the most powerful. It can detect basically any object on a video or on some images or even on your webcam. You know, I made an application last year and just for fun I was trying to detect the cars around me, the persons, and other types of objects. And this works very well, even if the car is not that close to you. And so the SSD implementations are not that abundant on the internet. The good news is that we make one in our deep learning and computer vision course, so feel free to check it out. I'm sure there are some other great courses that implement this as well, but if you trust us, we show you how to use it and how to have fun with it. And by the way, at the end of this tutorial, I will show you a very nice video we took as input of the SSD model of our deep learning and computer vision course. And now let's move on to the second amazing deep learning and computer vision model, which is the YOLO V2. The YOLO V2 is, for some people, even better than the SSD. It is not implemented in our deep learning and computer vision course, so feel free to check out some other courses. But since it is not implemented, right now I'm going to walk you through the video on YouTube. So check it out, take some images as input, and then create the same images, but completely designed by the computer, and that at the pixel level. For example, if I show you these two persons, would you say they are real persons? Well, probably yes, or probably not, because you know where I'm going right now, but you are really looking at human beings. But that's actually not right. We're not looking at human beings, we're looking at some people created by a computer, thanks to a computer vision model, or more correctly, a computer creation model, and these are the GANs, Generative Adversarial Networks, a super powerful deep learning model applied for computer vision, computer creation, and also you have the most advanced implementation of these GANs because they have several versions, which are the cycle GANs. So if you really want to go that far in that field, you have to go up to the cycle GANs. And you know, it's not like this deep computer vision model took a face and then replaced some eyes. No, it created these human faces at the pixel level by assembling the pixels in the right way to create an image that looks like a human face. So that's pretty amazing, and that's my 4 recommendations if you're interested in that field. So let's summarize it. First, start with OpenCV, then check out in parallel SSD, single shot multi-box detector, and the YOLO V2, and eventually check out the GANs, Generative Adversarial Networks. So natural language processing is basically the data science branch that allows to do a lot of magic with text or even voice. So if we talk about the classic natural language processing, well, that consists of taking some text as input and returning as output a class, like a category. For example, let's take the very classic example of sentiment analysis. Well, as input, you can have some text like some reviews or some articles or some Twitter tweets or even some messages, whatever you want, but the same kind of text. And as output, you will return if the text is positive, negative, or even neutral. You know, so for example, you can predict with NLP if a review is positive or negative. And this doesn't even have to be binary. Your inputs can be some books or some articles or some stories, and the outputs can be the jars of the text of the books. So for example, you can predict if a book is a romance or a drama or a comedy or even horror. So that's the classic example of NLP. And by the way, I highly recommend, because this course is to always recommend the first step if you're interested in a specific field, to start with sentiment analysis. And speaking of this, in our machine learning course, we have a full section, we have a full part on NLP, and we deal with the sentiment analysis problem because that's the best way to start. But then, even inside sentiment analysis, you can have some complex problems. For example, it's much more difficult to predict the genre of a book than whether or not a review is positive or negative. You can also predict the difficulty level of a text if you want to apply that to education, for example. Or you can try to tackle some even more complex problems. But sentiment analysis is the starting point of NLP. And then once you get some notions about this, then you can attack deep NLP, which consists of leveraging deep learning to make some fantastic applications of natural language processing. So let's talk about these applications. So first of all, you have machine translation. You can basically, well, not basically because it's not that easy, but you can build a translator like the one you use on Google, Google Translate, or whatever you want. You can build a translator by implementing a deep NLP model, which is the combination of deep learning and natural language processing. You can build this with a model called the sec-to-sec model, and which is the most popular and the most powerful model in deep NLP. This is the exact same model that is used to build chatbots, and I'll be talking of chatbots in a few seconds. But first, be aware that you can use the sec-to-sec model to make a translator from one language to another. And actually, on GitHub, you can find a lot of translator implementations using the sec-to-sec model, which is the main deep NLP model. And speaking of this, I'd like to recommend an amazing platform to use to build not only deep learning models, but also AI models, and of course, deep NLP model. If you go to PyTorch tutorials, you will see in the documentation an implementation of deep learning for NLP, which is exactly what we were talking about, deep natural language processing. So let's click on this, and you'll have a great explanation on deep learning for NLP with PyTorch, one of the most powerful. And moreover, if you're interested in that sec-to-sec model for translation, as I've just been talking about, well, you can just type here sec-to-sec, and what will you find? Translation with a sequence-to-sequence network and attention. So let's click on this, and there we go. You can find exactly a sec-to-sec implementation in PyTorch to translate, I think it's yes, from French to English. And you have all the code and all the explanations well explained. And of course, that's only if you want to go deep into deep NLP. So it's good to start with this. And now I'm going to move on to the second main application of deep NLP, which are, of course, the chatbots. You can build a pretty smart chatbot with deep NLP. And the good news is that it's going to be almost the same implementation as the sec-to-sec model for translation. Because, it works the same way. You have the inputs and the outputs. In translation, the input is a sentence written in French and the output is a sentence written in English. Well, for a chatbot, the inputs and outputs are kind of the same. The input will be a question or something said by yourself, and the output will be another sentence, which is the answer of the chatbot. So basically, it's kind of the same technique, and almost the only thing that changes are the inputs and outputs. And so now, how exactly does the chatbot learn how to speak? Well, the way it does this is pretty amazing. We feed to the chatbot a huge amount of text. The chatbot will look at all the questions or all the input sentences and all the answers or all the output sentences of these texts, and will learn how language works, how we talk to each other. And so these conversations can be anything. You can train your chatbot on all the Twitter conversations, for example, of 2017. You can train the chatbot on hundreds of thousands of conversations taken from movies, and that's exactly what we do in our deep NLP course. Or you can train it on any other text or on any other conversations. Basically, what you only need is input sentences and output sentences. And then the chatbot will understand how this works, how you know you need to start with the subject, yourself or anyone, then you add a verb, then you add something which makes sense based on how the conversations work. So basically it's kind of exactly the same as how a baby learns how to speak. A baby or a very young child doesn't know how to speak well at first, and it makes some kind of weird sentences in the very beginning, but then it learns by hearing his parents or her parents talking all the time how to say sentences that make sense. And that's exactly the same. Here, to build a chatbot, we train it for quite some time actually. It can take several days or even weeks to train a chatbot, so basically exactly like a child, to learn how to speak. And so that's pretty fascinating because, the goal of all this, the goal of deep learning, AI, and all that stuff is to build a brain, an artificial brain that is closer and closer to the human brain, how the real human brain works. I can relieve you if you're worried about all this AI conspiracy taking all over the world. We are still very far from the real human brain. Definitely check out the sec-to-sec model, but before this, if it's your real first step in natural language processing, don't forget to start with natural language processing first without any neural networks. And the model you need to check out for sure is the bag of words model, which is a model that cleans your text, make the inputs and outputs in the right format so that your classic natural language processing model can make amazing predictions. Alright, so I'll see you in the next tutorial for the final introduction of all these amazing data science branches, which is of course artificial intelligence. Alright, and let's finish with the final and most exciting application of deep learning. Yes, this is an application of deep learning, but I prefer to call it separately artificial intelligence. Here we go, that's artificial intelligence. Well, it's more fun and more exciting to call it artificial intelligence, but what it really is, and that's why I'm also categorizing it as a deep learning application, the other word for it, the more technical term for it, is deep reinforcement learning. Basically, you combine deep learning and reinforcement learning. Reinforcement learning is a branch of data science or a branch of machine learning, which is the foundation of artificial intelligence. All the artificial intelligence we managed to build today are based on reinforcement learning. And when you add deep learning to it, your artificial intelligence is even more powerful. So we can call it however you want, artificial intelligence or deep reinforcement learning. But anyway, that's the final and definitely most exciting application of deep learning. So how could I introduce you to artificial intelligence? The real journey of artificial intelligence. And this real journey comes in several steps. First of all, you're going to start with the basics of artificial intelligence, which is Q-learning. That's artificial intelligence without any deep learning, without any brain. So it's like a combination of mathematics equations, still based on this trial and error process, with good and bad rewards, but without any brain executing the actions. And that's the first step. You need to understand really well Q-learning. Because then the next step after Q-learning is to combine Q-learning with a brain. We are adding a brain, and that's where deep learning comes into play. Because by combining Q-learning and deep learning, your AI becomes what we call a deep Q-learning model. And that's the next step, to understand and to know how to implement the deep Q-learning model. But the deep Q-learning model is the simplest deep reinforcement learning model. That is the simplest neural network implemented for an AI. Because it only has neurons, basically. You only use a classic artificial neural network to build this AI. And so basically, this AI can only take some input data in the form of encoded data, with numbers, a vector of numbers that encodes what's happening inside the environment. And more precisely, we say that it encodes a state of the environment. Which means that your AI is actually blind because it couldn't execute some actions based on some visible, real observations. And therefore, you guess what the next step is. The next step is to add some eyes to the AI. And to add some eyes to the AI, well, we need to add the convolutional layers in the artificial neural network. And therefore, your AI becomes a deep convolutional Q-learning model. And that's really exciting because basically now you not only have an artificial neural network, you have a convolutional neural network inside the brain of your AI. And that's why with the eyes, well, your AI is able to see what's really happening in the environment to execute the future actions which are predicted by the neural network following the convolutional layers. And that's already a big next step. But then there is an even more advanced step, which is to add something else. Can you guess what it is? Well, again, this is all about trying to mimic the processes of the brain, trying to mimic the human intelligence, and therefore what we can add to it is some memory. And therefore, to do this, you need to integrate what we call an LSTM, a recurrent neural network inside the brain, so that not only the brain of your AI has eyes, but also some memory. And that becomes even more powerful and even more intelligent. So you can add this memory, and therefore your AI becomes a deep convolutional LSTM Q-learning model. The name starts to become complicated, doesn't it? But that's what it is, a deep convolutional LSTM Q-learning model. But that's not all. There is even another step. Again, can you guess what it is? Well, the other step is to add something else that we humans also have, which is a critic sense. A critic sense can be added to the AI, and that's actually the most powerful AI model you can implement today, at the time I'm speaking again in 2018, which is called the A3C, Asynchronous Advantage Actor Critic Agent, because it not only has a brain with some eyes and some memory and some neurons predicting the right actions to play, but also there is also this other brain which we call the critic, and that will basically bring this critic sense to the actions played, and that adds even more power to your AI. So there we go, that's all the steps of the AI journey. You need to go through these steps progressively, and I highly recommend to not only try to understand them, but to implement them, every single one of them. And I'm sure there are a lot of great artificial intelligence courses on the internet, but if you're interested in this path, if you're interested in this journey, that's exactly the approach we take. We build these successive steps of building an AI. First, a simple AI that has no brain. Then we add a brain to this AI, but only containing neurons. Then we add some eyes to the AI. Then we add some memory to the AI. And then we add a critic sense to the AI. And we do that for very exciting applications, such as a self-driving car, smashing Doom, or smashing the game of Breakout. And now, we're gonna finish this tutorial on an exciting note. Let's watch these two AIs playing Doom and Breakout. Remember, for Doom, it's gonna be a deep convolutional Q-learning, and for Breakout, it's gonna be an A3C, Asynchronous Advantage Actor Critic.
So in order to get the dataset, we're going to go ahead to superdatascience.com/intro-to-datascience. So this is the page on Super Data Science where all of the materials for this course are hosted. So you can download all the datasets here and any additional materials we talk about. And the dataset for today is in part 2, Data Science with Tableau, and we're going to download this one here, Bank Marketing Dataset. So there you go, it's downloaded, and now I'm going to go to the Downloads folder and unzip the file. So there it is, Bank Marketing Dataset. So right away what we're going to do is we're going to create a new folder on our desktop. For this course, it's going to be called Intro to Data Science. And then inside this folder, we're going to create a folder for our project. It's always a good idea to keep your projects in separate folders so that you know where everything is. Bank Marketing. So that's the name of our project. And here we're going to copy the files into this folder. Wonderful. So now we can just get rid of these two. And yeah, so there's our data set. We can open it up to have a look get a feel for it, what it's all about. All right, there it is. There's our bank marketing data set. As you can see, it's quite large and quite confusing at this stage because it's a comma separated, it's a semicolon separated values file. And if you scroll down to the very bottom, you'll actually see there's a lot of rows. There's 41,188 records, not including the header. And yeah, so it's quite a large data set. And what we're going to do is actually we're going to close this Excel and we're going to import the dataset into Tableau. You can use the menu here. You would need to select a text file because a comma separated values file is considered a text file. But what we're going to do is just going to take a shortcut and we're going to drag the dataset into Tableau like that. As simple as that. Tableau is a very drag and drop tool, as you'll see further down. And even when you're connecting to data, you can do that. And as you can see, it's identified the dataset as a text file. All right, so that's our dataset imported. Here it will show the top 1,000 rows, so you can just like scroll through them and get a feel for the dataset. And now right away they're much better organized. And so we're almost done. I'm just going to show you where you can find the information about these columns, what exactly they mean, and what this whole dataset is about. So there's a file here, dataset information, which will tell you a bit about the dataset. It comes from this source. You can also get it on the UCI machine learning repository, and Adlan will tell you a bit more about that repository in his tutorials on Python. But here's the dataset information. The data is related with direct marketing campaigns of a Portuguese banking institution. The marketing campaigns were based on phone calls. Often more than one contact to the same client was required in order to assess, I'm assuming this should be assess, not access, if the product bank term deposit would be yes or no, would not be subscribed. So basically, the question is the bank is trying to sell a new product or another product, additional product to their customers, bank term deposit, and so they want to predict is that person going to subscribe or not subscribe to that product. And so it's a real world data set. It's a real world problem. It's real world customers. Of course, it's all desensitized, or it's very similar to what was in the real world. And here we've got the information about the columns. So the columns that you see here, you can find information about them here. So these columns, they describe every single person that was contacted. So that's their age, 56. That's their job, housemaid or admin or blue collar technician. That's the marital status, married, single, there's divorced, there's a few other ones, education, default. So some of them are intuitive, like these ones, for instance, like basic 4 years, high school and so on. Some are not. So if they're not intuitive, you can just go back and find out what they are. And you'll see us doing this throughout the coming tutorials. So default, for instance, means has credit in default, yes or no. Does this person have credit in default? So usually it's no. Some of them are unknown. Some of them are yes. Housing, loan, like here, does housing has a housing loan, or loan has a personal loan. So does that person have a housing loan? Yes or no. Does that person have a personal loan? Yes or no. Contact is how was the person contacted. So here you see these are bank client data, the first ones. We've gone through them. Then we've got related with the last contact of the campaign. And then we've got some other attributes. So there we go. That's the data set. Oh, and by the way, at the end, the last part is the Y variable. This is the most important one. It's the yes, no variable, is the actual target. So has the client subscribed to a term deposit? It's actually what we know. We already know whether they or not they subscribe to a term deposit. We're going to be trying to predict that. We're going to be trying to see if there's any correlation with this variable among, between the previous variables, if any of them are correlated with this. So in the future, we can say, people with more education or with less education are more likely to subscribe to this loan, to this new product. So that's how it works, and you'll see all of this happening in detail in the coming tutorials, so don't worry if it's a bit confusing at this stage. We'll get through it. It's a typical data science problem, but we're going to be approaching it from a non-typical standpoint, so it'll be a bit different approach than what usually people expect or people would do with this data set. So that's going to be exciting. This one is actually coming before the Python tutorials, so that's super cool. Like, congratulations if this is indeed the first time you're solving a data science problem. Okay, so it's for the sake for that purpose, exactly that. Maybe it's your first time. I'm going to explain exactly what we're doing, and you'll notice when you do the Python tutorials, you notice a lot of resemblance in the problem itself with what Adlan is going to be talking about. But the way we're going to approach it is going to be very different. So let's go to this part. So here, I'm just going to use this file to talk about what we're doing. Let's do another enter here, another enter. Okay, so this variable I'm going to highlight in yellow. And then, or let's, you know what, let's highlight it in red. Let's highlight this one in red. And all of these other ones in green. And that will always help us remember which one's which. All right, so at the start, we've got some input variables. These are variables that we know about our customers, their age, their job, their marital status, their education. Have they ever had a default? Or do they have credit in default? Do they have a housing loan? Do they have a personal loan? Then some information relating to how we ran our how we last contacted them on this current campaign. You know, the contact type, was it a cellular, like a mobile phone, or a telephone, like a landline? What month was the last contact? Was it January, February, or December? Day of the week, Monday, Tuesday, Thursday, Friday. Monday, Tuesday, Wednesday, Thursday, Friday. Duration, how long was the duration of the call? By the way, here is a note to not use this variable because it's very highly correlated with the output, so it's kind of like cheating if we use it, so we're not going to use it. Then other attributes, campaign, number of contacts performed during this campaign, P days, like it means like number of days that passed by after the client was contacted from a previous campaign. So basically how many days passed since we contacted them last about a different campaign. Previous number of contacts performed before this campaign and for this clients, outcome of the previous marketing campaign, and then some social economic context variables which are not going to be really worried about: employment variation rate, consumer price index, and so on. And so basically these are all the things, as you can imagine, these are all the things we know or we can easily know at any point in time. Like if tomorrow we start working with, we pick another client that's not in this list of 48,000 or whatever number we had. If we pick a client that's not in this list, then very easily we can find out these things. We can just look at the information on file and, you know, like that we have about this customer or about our interactions with this customer. The question is, can we predict, based on this green information, can we predict if the client will subscribe to a term deposit, to what exactly our campaign is all about? We want to sell them a term deposit. That's our goal. That's the goal of the bank. And we want to, you know, obviously we want to approach customers that are most likely to subscribe to a term deposit, right? So even like, why would we spend our marketing budget and why would we spend the time of our employees on, you know, contacting people who are not likely to subscribe to a term deposit? So the way this data science problem works, or the challenge is structured, is knowing what we know about our customers right now, about our 48,000 rows, about our 48,000 people, knowing what we know, like all of this information from here, from the second last column to the left. So these are all the green columns, right? So let's just highlight a bit more like that. So knowing all of these green columns, is there a way we can, so let's do this actually. So knowing these green columns, is there a way we can predict what the Y column is? So, and this data that exists, already we know this column, right? We know the result. So this is like training data, because in this data, we know what happened. We know in reality, this person didn't subscribe. This person didn't, but this person did. So it's like in real life, you have all of these iterations, like you have all of these examples from which you can learn. And you can maybe learn that people that, let's see, what is there? Like, why is this person special? Why did they subscribe? Maybe because they are, you know, maybe it's the age that affected their decision to subscribe. Like maybe we'll see that age is correlated with people taking up this term deposit. Maybe it's that they're an entrepreneur. Maybe it's that they're married. Maybe it's that we contact them by telephone, but doesn't really look like it. It looks like, you know, a lot of people who we contacted by telephone didn't subscribe. Maybe it's well, duration of the call, we've already been told that it's highly correlated, so we're not going to use it. Maybe it's the day of the week. Maybe if we call on a Monday, they are more likely to buy the term deposit or get the term deposit. Whatever it is, the point is that we can use this existing data to make better decisions in the future. And that's what data science is all about. So if we have all this data for, and I think this data was collected 2008 to 2012 or 2006 to 2012, you know, like for quite a few years, for like 4 years or something like that. So if we have this data for a certain period of time, it's actually an asset. It's an asset to the company, and the purpose of a data scientist is to realize how to use that asset, how to use that information, turn it into insights to drive decisions in the future, to drive better, smarter, wiser decisions that will save money, save costs, and improve efficiency. And that's exactly what we're going to be doing. So we're going to be using these green variables to understand which ones of them are correlated with this red variable. So in the future, we can just make decisions like that. For instance, we might say, the best people to contact are entrepreneurs. We're going to contact them first, and then we're going to contact everybody who has a housing loan, and at the same time, we're only going to call them on a Monday, because that's the best way to do it. And if we give those insights to the operations department or to the CEO, they're going to save a lot of money because they need to contact another 10,000 people this year. So that's what we're going to be doing. And I know you were probably excited about starting to visualize right away. We will jump into visualization in the next tutorial. I actually just realized as I was recording this that it's better to first explain the problem, because this is probably, for many, it might be the first time you're doing a data science problem. And we'll get to it. Sheet 1 over here. Let's click this button. And this takes us to a completely different workspace. So this workspace, the data workspace, is where you load the data. This workspace is where you actually create the visualization in Tableau. So I know it might be a bit confusing, but don't worry, you'll get used to it. It's very intuitive. It's all drag and drop and very straightforward as well. So without too much preamble, we're just going to start visualizing, and you will get the hang of what we're doing as we move along. All right, so we're going to take our variables, which you can see here on the left, dimensions and measures. And by the way, you also notice that some things you will get a hang of, some things you probably won't, because Tableau is, even though it's a very intuitive tool, a simple tool, it does require a bit of learning. But that's a topic for a separate course. Like, we have a course on Tableau. You're welcome to explore that, or there's tons of materials, free materials online, where you can learn Tableau or bits and pieces of how to do things in Tableau. You can also take other courses. There are lots of courses available in Tableau. So let's have a look and see how we go. We're going to take this variable y, which is the variable we're trying to predict, and we'll put it in color. And next, what we're going to do is we're going to build a way for us to, a visualization that allow us to compare how a certain variable works. So I'm just going to check here. We're going to start with a variable called contact. Where's contact? There it is. Contact, if we go back here, is, there it is. Contact communication type. Did we call them by cellular? Do we call them on the mobile or on the landline in the last contact of the current campaign? All right, so let's have a look. We're going to take contact, and we're going to put it, we're going to put contact into, just drag contact into columns. So you can see here, cellular, telephone, and then we're going to just take a number of records. So that's the number of rows in each of those categories. I'm going to drag it into rows over here. As you can see, it's telling us right away, it's very smart. It's already built a bar chart for us. So let's make some space here. And it's telling us how many people were contacted. So we're going to take this, and on a Windows, hold down Control. On a Mac, hold down Command to copy it. So if I just drag it without holding anything down, you'll see that next to the mouse is just like a little square, or rectangle. But if you hold down Command on a Mac or Control on the Windows, there's a plus, meaning that you're copying this, and copy it into label. Drag it into a label. Now all of a sudden we have a label which tells us All right, how many people did we actually contact? By the way, if you want to change the colors, you can click edit colors and you can change them over here. So just click no and you can change it to purple or whatever, but I'm just going to keep our current color palette. All right, so it tells us that we contacted on cellular, we contacted about 26,000 people. Of them, 3,853 said yes to the term deposit, eventually did subscribe to the term deposit. And then 22,291 said no. And out of the landline, 787 said yes, and 14,257 said no. Okay, so that doesn't tell us much because we can't really compare them. So which one is better? Is it better to call on their mobile or is it better to call on their landline? Who is more likely to say yes? So we can't really compare them right here because they are different in size, right? Because this bar is generally bigger, so we can't really tell what the percentage of people we called here, is it greater than the percentage of people we called here or not? So that's exactly what we're going to do. We're going to introduce the percentages. So we're going to convert this from just a sum to a percentage. So click the drop down and click quick table calculation, percentage of total. And then we're going to click this drop down again, and we're going to select compute using table down. Instead of table across, it's now calculating the percentage table down. And to illustrate what it's calculating, we're going to now take this again and again move it to label, holding down command or control. So we're copying it into here. And this time it's going to add another label because it's different, because we've already made modifications. And so this one is the one without modifications. That's the absolute value. This is the percentage. And here we're going to click format. We're going to go to numbers. We're going to select percentage, and we're going to change the decimal places to, yeah, let's just do 0 decimal places for now. We'll change it back if we need to. So there we go. So that should be a bit better now, a bit better formatted. And so now we can see that the total in both cases is 100%, right? And for our reference, we still have our previous label here, which says how many people we actually contacted. The absolute values are referenced here indeed, 22,291, 3,853. But now we've converted this table into a percentage table. And so this is what we're going to be doing. We're going to be just comparing visually what is better. You know, what percentage is the higher percentage? What percentage, which approach, cellular or so mobile or landline, has a higher conversion rate? So in the case of mobile, 15% of people out of the respective absolute value here, 15% of people said yes eventually. And out of the landline, only 5% people said yes eventually, out of the absolute number here. And that way we can compare them side by side, because they are not, no, they're no longer relative. They're no longer absolute values. They're in percentage terms. So we can make this comparison. And so next time when we contact someone, it's pretty obvious that if we have an opportunity to call on mobile, we should call on mobile, because it looks like people are more likely to respond yes. It might be like the reason for it might be, you know, maybe people are more friendly on mobile, or maybe just the people who still use landline are not that interested in our product, and the people who we contacted by mobile, maybe they just don't have a landline. And that way we'll just pick out those people that have mobile on their accounts rather than landline. So the underlying fact, the underlying real world reason for it can vary, but what we can see from the data is indisputable. We can see that this percentage is higher than this one, and the numbers are quite high overall. So it doesn't look like just a random error. It doesn't feel like this happened randomly. It looks like a trend or pattern. And that's what we're looking for, patterns. So there we go. That's our first analysis of a one variable. How do you feel? This is what I personally call visual data mining. We're using a visual tool to extract insights from data through sight, through our eyes, rather like through images, rather than performing analysis. And this is like performing complex machine learning type of analysis. And this is what I mentioned at the very start, that the way we're going to approach this problem, like this problem as described over here, is a classic problem for data science. And usually the way it's solved is through machine learning, through applying some sort of machine learning algorithm to predict this variable. And that's what you will do at LUN in the Python part of the course, in the next part of the course, which is dedicated to introducing you to machine learning. What I wanted to show you here is that even complex problems like this, we can still solve, not as perfectly, not as amazingly as you could do it with machine learning, but we can still get insights into these problems with very simple tools. It took us like 5 or 10 minutes to set this visualization up, and as you'll see in the next tutorials, we will punch out like another 5 at least of these very, very quickly based on what we already have. But the underlying point is that machine learning is great and it's always good to go down that path, but also the whole just idea of data science is much broader than just machine learning. And you can use visualization tools like Tableau, not just to create beautiful visuals, but also to perform data mining and get insights very, very quickly and, act on them and make recommendations based on those insights. So there we go. That's our start into the world of data mining, and congrats on making your first step. By now you've probably, or you may have tried to save your work, right? Like after this, I always like to press like Control S on a Windows or Command S on a Mac, and to actually, like save my progress. But if you press Command S in Tableau Public, what you get is this. Or let's just close this window for now. And if you go to File, Save, there's no Save button. There's no Save button. There's a Save to Tableau Public. There's a Save to Tableau Public As. So what is this all about? Well, the reason for this is that Tableau Public, it's a free version of the software, and it comes with certain limitations. And one of those limitations is that you cannot save the file to your desktop. You cannot save your work on your own computer. And that's fair enough because it's an amazing software and they obviously need to somehow fund their research and development in order to progress. So that comes from people who pay for the public Tableau desktop version. And in the Tableau Public, what they do provide is an option to save your work publicly. And that means you will save it on their server, but everybody in the world will be able to access it. And that's so basically try avoid using Tableau Public for sensitive data and for work-related data, but for practice, you can always use it. So there's no problem with that. So in order to save your work, you click Save Tableau Public. You need to create an account. You put it like you create it. Here you would log in, or you can just click create one for free. You'd put in your credentials here, check the terms of service, and create your profile. And so here I just wanted to show you what it would look like to have an account. So if we go to Google and we go to Tableau Public, let me open it up here. So there's Tableau Public, and if you go to, at the top, if you go to Gallery, you'll see everybody else's visualizations, like, the popular ones. So he's got Viz of the Day and things like that. There's lots of visualizations that people are actually building, and you can explore them and, comment on them and see what other people are doing. And these are all the things that are possible in Tableau. I wanted to also show you my profile here just to demonstrate how this whole thing works. So curl Minko. Give it a second. So if you scroll down, these submissions, you'll see there's like 280. That's because I'm very grateful for this, by the way. Like a lot of students from the other courses are uploading their work and tagging me in it. But if you go to my profile, you'll see that I also have a profile, and I've uploaded some projects of my own. So basically what I wanted to show you is that there's nothing like bad about having your data available publicly, as long as it's not sensitive or personal data or private information or work-related data. As long as it's practice projects like we're doing now, like I actually encourage students to upload their projects here and to share and to show their friends and colleagues and, you know, like maybe family, or get feedback from others. So here you can see like one of those examples from one of our other courses where we're doing some more advanced analytics or building a dashboard and things like that. So yeah, that's just a quick note on Tableau Public. So don't be worried if you do want to save. There's nothing wrong with your machine or with your version of Tableau. That's just how it works. If you do want to proceed, then feel free to create an account and you can save your work. But otherwise, even if you don't, it's okay as well, because you can just keep it open until we get to the end of this section. There's only a couple of tutorials left. And then when you do the next project, you can just start a new dashboard or a new Tableau workbook. So there you go. That's how Tableau Public works. And we'll continue analyzing this on the next tutorial. If you haven't played around yet, then I encourage you to do that. You know, check out a couple of other variables. You know, what happens if you look at, I don't know, like education or day of the week and things like that. And then we'll do it. We've gotten that to this stage where we've created a very useful tool inside our workbook, which allows us to analyze the effect of certain variables, in this case, the way we contacted a person, on the outcome. So here we know that people who we contacted through mobile or cellular had a 15% chance of taking up the offer in the end, and people who we last contacted by landline only had a 5% chance, or only a 5% conversion rate. It's not a chance, it's a conversion rate. 5% of those people converted. And let's just reiterate, the key here is that we put these into relative terms rather than absolute. So in absolute, of course, there's more people in this box. You know, there's 22 plus 3,000, whereas there's only 14,000 plus 700 here. So a larger amount, but not a larger number of people. But if we put them in percentage terms, then we can compare side by side. Okay, so that's what we did for mobile, or I mean contact, right? So let's rename the sheet. So if you double click on this name here, sheet 1, and you can change the name. So I'm going to change it to contact, so we remember. And so now let's look at another variable. Let's see, what else do we have. Let's look at the marital status. And instead of creating everything from scratch, we're just going to click on this on a Windows right click, or on a Mac hold down Control and left click and click duplicate. And so now we're going to rename this right away to marital. And all we're going to do is, this is what I love about Tableau. It's so quick to change things, so quick to create visualizations, all drag and drop. It'd be so much harder in other tools. So if you take marital and you drag it and you just put it over contact, like replace it, bam, everything is done. That's it. So as you can see, because contact only came up once, now everything is about marital all of a sudden. It's we're analyzing the marital status and who which people with what kind of marital status ended up having a higher probability of taking up our offer, or what had a higher percentage of uptake or higher conversion rate for our offer. All right, so here we've got marital. As you can see, we've got 4 columns now. So before it was more like an A/B test, cellular versus telephone. Here we've got 4 columns. We've got divorced, married, single, and unknown. And so what can you tell from this? Like, try to be a data scientist. Maybe pause this video and try to look at this and decide for yourself which ones have a higher conversion rate, which ones are more likely. Well, it's pretty straightforward, pretty obvious from here. From the way we've structured this, it's very easy to tell. It's very easy to tell that people who are single were more likely to take up our offer. 14% out of the people we contacted. Again, this is all in relative terms, right? 14% of the total number in this column. We don't really care what the number was right now, right? We don't care that this number is much greater. It's 25,000 here, or almost 25,000, whereas there's only like 10 or 11,000 here. But in relative terms, there's no difference. And again, I'm just going to remind you that, just double check that here you have, what do you have? Quick table calculation % of total checked off, and compute using table down. If you have compute using table across, you'll have a different picture. It won't be the same. It has to be table down, meaning that the percentage is calculated in every single column separately. And same here. So in this one, you just have the sum, measure sum, but in this one you have quick table calculation, percent of total, and compute using table down. So here we can see that single people had a much higher, not much higher, but a higher chance of a higher conversion rate. Now, why am I not pointing out the unknown? The reason for that is, first of all, they're unknown, so most likely, like, we can't really do much about it, right? Maybe we can. Maybe there's like a field in the field we can like leverage that the field does say unknown. But the thing here is that, and maybe you picked up on this, the thing is that there's only 12 people in this category and 12 plus 68 here. So in total, there's 80 people in this whole column. It looks like a lot because we've put them in absolute terms. In relative terms, they're all kind of like up to 100%. But in reality, there's like, 5,000 or 4,500 here, 23, 11,000, and then there's like 80 people in this column. So what this means, and this is something to look out for, that this could actually be a sampling error, or this could be just like a random effect. It just randomly happened that we picked 80 people, the 80 people that are in this column, they are just somehow for other reasons more likely to sign up to this offer rather than, their marital status. And that's an important thing to always remember in data science. And that's why this is a good illustration of why in our guide for getting into data science, statistics is at the start, right? Like, you don't need to know complex statistics. You don't need to know a lot of statistics, but the basic things you need to understand a little bit. Like, for instance, you need to understand that this is not a statistically significant result. That, if you have 11,000 here, that's statistically significant. It's very unlikely that this happened at random, that this effect is a random effect. But it is very likely that this is a random effect. We cannot say with certainty that this will be, going to be replicable in the future. So that's why we're going to disregard this, and we're only going to talk about these. So just something to keep in mind, and it's a good illustration of why statistics matters and to what level it matters. So all we need to understand is kind of like have a feel for it, and of course, before you present the results, you would run, if you were to go ahead like with this, you would run some statistical significance results and check them. But we're not going to do that now because we're focusing on visualization. So let's do quickly a couple more. Just duplicate this one. And what do we want to look at? We want to look at education. So just drag it over here, replace, rename. Don't forget to rename. Always good to have things organized. And here, again, so here you can see this one looks higher, but this is probably a insignificant result. It's got 4. So you can actually just right click and exclude. If you are probably better to exclude the whole thing, or just click here and right click and exclude so it doesn't get in the way. Anything you feel is statistically insignificant, as a rule of thumb, try to go for at least 200 observations, like everywhere, like in each of these boxes, at least. That will kind of keep you safe, but still in some cases it will still be statistically insignificant. So like, what do we see here? Unknown is unknown. Well, we can see that people with a university degree look like they're more likely to take up the offer than people who are most likely to take up the offer, right? Or especially people who have like 4, 6, 9 high school professional. So maybe that's something worth pointing out. Let's do another one. Duplicate that. We're looking for like stronger effects. Let's see if we can find anything stronger. So put this in, and you notice that probably that thing I showed you about excluding is probably don't do that because it adds a filter here, and we don't want to get into filters right now. So just right click here and remove this filter so that this this unknown comes back. And so you see this filter is affecting our next slide, right? So or at least make sure you don't have filters when you proceed to the next slide, because otherwise it can get confusing. Okay, so what do we have here? If we add, so now we put in loan, right? And loan means that do they have, so we can go back here, we can always reference this. It says, let's have a look. Where is loan? loan? Do they have a personal loan? So the people in so at the bottom we've got people who don't have a personal loan, people who have a personal and unknown. As you can see, there's no change. This has no effect, and also these are quite statistically insignificant, especially this one, 100. These ones are maybe more or less okay, but nevertheless, there is still nothing to observe anyway. They're all 11%. So we can tell from here that most likely it doesn't really affect their decision to take up the product. Whether or not they have a loan, a personal loan, doesn't really affect their decision to take up product. All right, let's duplicate this again. Let's do one more. And this one's going to be month. Let's see if it affects what month we call them in. And here we see a much different picture. Very interesting as well, right? So, and all of these look quite good, except for the December one, which has like 89 observations. The rest have, at least 200, 400. But you can see the dispersion, the diversity of all of these. Some are higher, some are lower. This is crazy. So what we're going to do is I'll leave you to explore this and try to understand why are certain months higher, certain months lower, just based on what you know about what happens in certain months. And then we'll talk about it together in the next tutorial. And also I wanted to suggest a quick for you, like a quick thing for you to look at on your own. So we're not going to go through all the variables now, but have a look at the next ones on your own. So look at housing, day of the week, and did they take up their previous marketing campaign or not. So have a look at those on your own. Again, it was housing, it was day of the week, and P outcome, and see what you get. So that will be some good practice. Remember, data science is all about practice, practice, practice. So analyzing this and trying to understand what these insights are saying and why they're saying that, and also doing those 3 variables, that'll be good practice. Homework to create the following 3 variables: housing, day of week, and P outcome. So I've already got them created here, and we'll look at them in a second. But for now, let's discuss month. So what's the first thing that stands out? First thing that should have stood out when you were looking at this visualization is that somehow we only have 10 months. January and February completely dropped out of this visualization. They're not here. So first thing we'd look at is filters. There's no filters on. So that means they're probably not even in the database or in the data set. And so what in a proper end-to-end data science project we'd do at this stage is we would actually go back to the original data source and make sure that we haven't lost any data along the way, because it's quite strange that January, February are not here. And so don't worry, I've already double checked. I checked the original data source and data set, and we truly don't have January and February in there. And so now we just have to try and understand why. So the next thing is, we already discussed that we're not going to look at December because it looks like it's not really statistically significant. It's about 89, 93 here compared to, like we've got a lot more variables in the other ones. And so this could be a random effect that it's like almost, half the people we contacted in December decided to take up the term deposit. It could be a random effect because it's not a statistically significant result, most likely, and therefore we're not going to look at it. And again, this illustrates the importance of statistics, or just basic understanding of statistics in data science. And this actually gives us a clue as to why January, February might not be available either. The thing is that people spend a lot of money on Christmas, New Year's, and other holiday presents during the December festive season. And that's why in December, they're kind of like saving up money in order to spend it on the presents. And then in January, February, they simply don't have that money until they get paid several times from their job. So they get paid for January, and then they have to pay off their credit cards. February is usually the worst month for retail, and you get to see that in practice as you do data science projects in the retail industry. You see that like huge dip in February in terms of sales because people are still paying off their credit debt from December. And maybe that's exactly the reason why this bank is not proposing this product to their customers in January and February, simply because the term deposit requires a customer to put money into the bank for 6 months or 12 months or 24 months for a fixed period of time, and then they cannot touch the money in that time. In exchange they get a good interest rate. And so maybe the bank has already figured it out that January, February are really not the best months to contact people. And as you can see, maybe they've also thought the same about December, that there's quite, that's why they didn't do a lot of contacts. And so that could be that could be the reason why January, February are not in here. And now let's have a look at the other months. What did you discover here about the other months? Well, we can see that the term deposits in March are quite high, or the people who took up the offer is probably the highest month. Maybe the reason here is that people actually got paid. And now they have some money they've saved up, they haven't been buying presents and so on, and they're willing to invest it into make some interest. What else? We can see that April kind of drops off. Maybe it's because a lot of people invested in March and now they don't have enough money to do that again. May, I'm not really sure about May, why it's so low. June, July, August, I would say is probably because of the summer holidays, and maybe in May, people are saving up to go for a trip in the summer holidays, and that's why it's low. And then summer holidays, June, July, August, people are just not at home, or that's not what they're really worrying about. They're spending time with their family, with their kids, or going somewhere. And then it goes back up in September because everybody's back, and now they're, kind of like starting a new educational year in terms of school, but like the adults, the parents bring their kids back, and maybe they're rethinking their finances. October, again, similar on kind of like in that sense. But then November drops. Why would November drop? Well, similar to this situation, that they're probably saving up for December to spend money there. Again, we're not looking at this at all. So they're probably saving up for December. And also in November, we have Black Friday, right? So in Black Friday, people spend a bit of money. And that's another reason. So there you go. That's an example of how interesting data science can be. Like, we're looking at a picture, but we're applying so much other knowledge right away to assess why this is happening. Another thing I wanted to point out here as well is that these effects, they're not secluded, right? So there's also other variables, and the combination, what we're seeing here, people taking up this term deposit, is also affected by other variables. And nobody's guaranteed that, for instance, I don't know, the marital status of people we're contacting is consistently the percentage of married versus divorced versus single is consistent across the months. Maybe in March we just contacted more single people for some reason. So there might be some correlation between the variables, and that can be affecting these outcomes. So that's just something else to keep in mind. We're not going to delve into that. Just wanted to put that caveat out there that there are other things to consider, and that comes with like additional statistical information, knowledge, or when you apply machine learning. But through basic visual analysis, you can already get some valuable insights. That's, like you can already say that some months like March, September, October are most likely better than the other ones. All right, so let's have a look at these other variables. So housing, if you did this variable, you probably saw that there's not much effect here, nothing to talk about. Day of week, similar, not much effect. The 2% difference, even though 800 and 953, the difference is so little, it's only 2%. And the number of people, like, in order for that to be statistically significant, I'll just give you like a quick insight into the world of stats. Like, for that to be statistically significant between 2 and 10%, the number number of observations in each of these cases would have to be much greater than it is now. So even though they're high, they are not high enough to prove that this 2% difference is statistically significant. So what we would conclude from here is we would say that there's not enough evidence to suggest anything about day of week. So basically, any day of the week you contact them, there's the same likelihood of getting that term deposit. And P outcome, so here we've got an interesting example, right? So here we've got a huge difference, right? So if we contacted them before and it was a successful campaign, right? P outcome is, what is P outcome? P outcome of the previous marketing campaign. So if it was a successful marketing campaign previously, then this time they're more likely to subscribe, to take that term deposit. 65% chance that they will take. So that's a huge golden nugget we found in there. It's kind of expected, right? So if a person already said yes to our product or a product before, then they kind of like maybe they're loyal to us, they like our bank and so on. So they're probably going to say yes again. So it was expected, but this percentage is really high, 65%. So that's really good. So something to point out. And then this one is interesting. If we didn't contact them before, if we didn't even approach them at all, then the percentage is 9%. But if we contacted them and we failed and they didn't take up the offer, the percentage is 14%. And the numbers are quite high, 600 and 3,000. So there can be something going on here. And so that's very interesting because I would expect the opposite. I would expect if you failed to contact, if you failed to sell them something before, then you're not likely to sell them something again this time. And maybe people who you haven't approached at all, then you're more likely there. But in reality, as we can see, it's better to contact people who we failed to sell something to before than people we haven't contacted at all. So basically, you would contact them in this order. You'd contact people who you've successfully sold to before, then you'd contact people who you've unsuccessfully sold to before, and then only you would spend your time and resources and energy contacting people who you haven't contacted yet before. Interesting insight. So this was expected. This was probably unexpected. You'd always obviously test the statistical significance there, but again, we're not going to go into that. It looks kind of okay. But obviously, before presenting this to an executive, you would make sure that it's statistically significant. This is just a very simple calculation that needs to be done. So far, we've been working with dimensions, and dimensions are actually categorical variables. These are type of variables that are yes/no variables, or they say a day of the week, type of education a person has, the marital status, so it's basically words or categories. Day of week can be considered a category. These are all categories. Months, these are all different types of categories. So what category does a person fall into? Whereas here we've got numerical variables, which are different in the sense that you cannot consider them categorical. These are continuous numerical, some of them are continuous numerical variables, right? So for instance, you've got age, right? So a person, you cannot just categorize them by age, because they could be like 3.5 years, or they could be 3.12 years old, or 3 is probably not the best example, 30.5, or 29 years and 2 months and 1 day, and things like that. So it's not easy to bucket people among these. And so let's see what happens if we give it a go, right? So if we duplicate this sheet and we take like age, we're going to be working with age, so we can just rename this. So if we take age, for instance, and try to do the same thing, first of all, it doesn't replace, and even if we try this, something else comes up, right? Something completely different. And we can probably build some interesting charts around this, but we can't apply the same exact approach, right? We cannot just say, just replace age there. Simply because it's not a categorical variable. And so what we're going to do is we're going to create a categorical variable out of it through bins. We're going to create, we're going to bin age into groups. And so you'll see how we do that. So if you just right click and you click create, and you create bins, and then you say, don't worry about anything else. We're not going to go into detail here. Just say size of bin 5. So the bins are going to be 5 years, each bin there. And now you can see a categorical variable here, age bin. And so, by the way, before we do this, I wanted to show you that if you take your age bin and you put it into columns, and then you put number of records into rows, you'll see a distribution. You'll see how people are distributed across that across those bins. And this is what I mean by bins. Instead of having, so if I go back to age, instead of having, if I just take age like this into columns, right? Can't really do much with it, and even if I take number of records now, you can't really do much here because it's just doing that. But here it's binning them up because it's showing you've got now categories, right? You've got 15 years, so that's 15 to 20, 20 to 25, 25 to 30, 30 to 35, and so on. So each bin is represented by the lowest age in that bin, 35 to 40, 45, 40 to 45, and so on. And this shows you how many people are in each one. So you can press down Control and copy that into color, and it looks even nicer. You can add that to label. Now it puts a label on top. It looks really nice, right? So you can create a really nice chart like this. So you now know how your people distributed, or as we know, you could add a quick table calculation, and you could do percent of total, right? So you know how many people fall into which group. So 22% of your customers are between 30 and 35. As you can see, by the way, that's one of the powerful things about Tableau. How quickly did we create that visualization? Very quickly. But that's not the goal here, right? So our goal is analytics. We're trying to, we can create visualizations. That's another thing that we can be doing in Tableau. But for now, we've set ourselves a challenge to explore age, right? And so now we have age as a bin, and we can pull it into P outcome, and bam, all of a sudden you see how this, the whole thing works out with age. Which people are more likely to take up the offer, which are less. Always remember the statistical significance thing. This is not really as well. None of these are really significant. But here at the bottom, you can see that kind of like something interesting is happening, right? So you can see that the middle ages, between 35 and 50, they are low, or maybe 35 to 60 even. They have quite a low percentage of subscription. But the younger people between 20 and 30, they have like a higher percentage, right? So that's something interesting to observe. Again, these are data looks like statistically significant, especially this one with 2 and 3 variables. But there could be something going on here. Like, it's not to say that it definitely isn't. They might be, but we just we don't have enough evidence to say that it is. But already you can pull some information out from here, I guess. So that's kind of like one of the drawbacks of this visual method, that unless it's statistically significant, you can't really say much, and that's where machine learning comes to the rescue. What I wanted to say else here is that you can also practice with these bins if you like for other variables. For instance, p days could work, previous could work, and you can find the descriptions over here. But we're not going to delve into that further. We're going to stop here. So you can continue exploring, but I think this illustrates the power of visualization for data mining, for driving insights. There are other ways you can apply visualization. You can apply visualizations to create beautiful charts and beautiful graphs and so on, and present things in a very coherent manner. And that's also very important in data science. But here, at least, we explored this first component. I think it's very powerful. Like, it's not only just about creating charts and graphs, but it's also about the data mining aspect. And it shows you that you do have a lot of power in your hands already, even not knowing complex statistics, mathematics, statistical learning, machine learning, deep learning. Even without all those things, you already have quite a lot of power in your hands with simple tools like Tableau. We only used it in one specific application, which is visualization for data mining. And as you can see, we did come up with some very interesting insights and some valuable recommendations. We could make some valuable recommendations from these insights. However, it did feel very repetitive, like mundane, and we're just doing the same thing, same colors, same type of charts. So it wasn't like, it was fun from the point of view of the insights and finding them, but it wasn't really fun from the point of view of visualization. And I wanted to use this tutorial to showcase that it's not always like this, that in data science, the other side of visualization, the creating beautiful, stunning images and dashboards, is also very important. And it is possible even with tools like Tableau and beyond, of course. And so I wanted to start by showing this chart. Remember how quickly we created it, how just by dragging and dropping a couple of things, we created a chart which talks about the distribution of our customers across different age groups. And here's a few illustrations from there. So for instance, this visualization, as a challenge in the course, I actually created it. I was timing myself when I created it, and it took me less than 5 minutes to create it. And it shows the profitability of a certain store across different states in the US. And so again, it's all just drag and drop, and you have a map of the states. Here's a chart which illustrates long-term unemployment in the US between 2005 and 2015. And long-term unemployment is 27 weeks or longer. And you can see how it was changing. You can see like the huge spike after the GFC, after the crisis, or when the crisis was underway. The spike started, or this trend, the upward trend started. And we can actually see that. And also it's split by age groups. And this type of chart is called an area chart. Then we've got an example of a dashboard. It's interactive, and this is showing us different things like information about a store. So, the profitability of a store is in different parts of Europe. So the profit margin is shown here in color, and the sales are shown as the size, and then you've got the customers. And so when you click, it will highlight the different customers relevant to that store, and then you can find more information about them if you like. So that's this visualization. And finally here we've got another visualization, a dashboard, or actually a storyline, which we've touched on a little bit, but we didn't explore it further. So a storyline is like a dashboard. You can also click around here and things will be interactive. But storyline has already some preset information, preset insights here. So you can just scroll through it and you'll see different insights that have been outlined for the person reading it. So you can see different comments about the different parts of the UK and what's going on there. So there we go. Hopefully this illustrates that visualization, and especially Tableau, are not just as boring as just getting repeating the same visual all the time. All of these charts were also created in Tableau. It's all possible. It's all drag and drop, and these don't take that long. So you can have a lot of power in your hands, not just through an analytical sense, but also from a visualization standpoint and creating beautiful insights with tools like Tableau, and there's a couple of other tools that are available on the market as well.
As we are done with Tableau, next is on Python for data science. As a data scientist, we must know Python basics. So, please check out our Python playlist that we have made it so easy to you understand.
Here you are on the page from which you can get access to the virtual machines inside Amazon's, and we call them actually the EC2 instances, which most of them are Linux virtual machines. So what exactly does this mean? This means that you will be connected from your place to some powerful virtual machines far from you. They can be in one state of the United States or in some other states. So they will probably be far from you, but it's as if you had this computer in front of you and you can use it to do some machine learning. So that's pretty amazing. And Amazon Web Services contains one of the best virtual machines. So here you can scroll down to see all the products they offer. I told you about Amazon EC2, which are the virtual servers in the cloud. So that's the main and most widely used product of Amazon related to machine learning. So we can already click on this, Amazon EC2, and there you go. You can already get started here. They have an amazing guide, and they even offer you a free trial. You can try Amazon EC2 for free, and the guide is amazing. They show you step by step so that you can really follow the process. All right? So Microsoft Azure Cloud Computing Platform and Services. Definitely this one. Here we go. That's the third cloud platform I highly recommend to check out. No worries. Again, I'll give you my best recommendation. So your vision, your cloud, and as you can see, Azure has more than 100 services with great end-to-end tools to make you successful. Okay, they're hybrid, intelligent, trusted. Definitely Microsoft is a great brand, and you can feel safe using their cloud platform. All right. And again, if you're interested in checking it out in more details, you just need to go to product here, and there you go. You can find the virtual machines. virtual machines, provision, Windows, and Linux virtual machines in second, you'll see that most of the virtual machines offered on cloud platforms are either Linux or Windows virtual machines. But I can already give you my recommendation that it's better to use Linux virtual machines. In general, when you do machine learning, deep learning, or artificial intelligence, Linux is more recommended than Windows. And even I'd say that Linux is the best operating system to do some machine learning or artificial intelligence. So at least whether you choose Amazon, Google Cloud, or Microsoft Azure Cloud, I recommend the Linux virtual machine instead of the Windows virtual machines. But there you go. That's where you can connect to virtual machines on the Microsoft Azure Cloud platform. And here again, you can start free. You have a nice guide that explains you well the process of setting up a virtual machine and use it. All right, so that's another great one. And now, next one, that's the first link, of course. This is not just any cloud. This is the IBM cloud. There we go. This is one of the best clouds for sure. I'm not telling you yet which one is my favorite, but this one is also really, really good. I'm not saying that I used all the cloud for a long time. You know, I didn't develop some machine learning applications for big projects on all of these clouds. I just want to be honest on that. The reason why I'm recommending you this is, first of all, I did a lot of research, I experimented, and mostly I asked around. You know, I have a lot of people in my network who are data scientists and artificial intelligence engineers or machine learning scientists, and they use a lot the clouds. And I asked them, which one is your favorite? Which one do you use the most? And that's how I could get a good idea on which are the best, you know? And also what's important to know is that not everybody has the same favorite cloud platform. So it's good that I introduce you to the best so that you can see which one you feel best and also which one would fit the best to your project, to the way you work, to your constraints and your goals. You know, that depends. But anyway, the IBM Cloud Platform is another great one. And again, if you want to check it out in more details, you just need to click Products here. And by scrolling down, you should find the Cloud Virtual Servers. There we go. These are the ones. You can just click on them. And then not only you have a great explanation on what virtual servers are, but mostly you can sign up to do some great and powerful machine learning on their platform. All right, so another one among the best. And now a final one, which you might not have heard already, but this is also a great one that I must introduce you to by the website that it's an innovative cloud, you know, built for the future, powering next generation applications from VFX to machine learning. Here we go. So if you want to do some powerful machine learning that requires some great computer resources, you can also consider Paperspace. That's a great one. So as you can see again, here we go, effortless infrastructure for machine learning and data science. This is really a great one actually if you want to start, because it's one of the simplest to start, and you know you can easily run your Python modules or Jupyter notebooks on this cloud. So it's to be highly considered. All right, and so if you're interested in checking it out, well, again, you need to go to products. You know, it's always the same. You have to go to products and not solutions. So products, and then you need to go to core, because that's where the servers are. Then you can not only request a demo, you can also get the guide, which is a great guide and which will definitely help you in the process of setting up Paperspace very easily. And we can see that really it's a recent website, quite innovative, quite user-friendly as well. You know, right now it makes me want to try it again. So there you go. That's my last recommendation. These 4 cloud platforms are really amazing. And now in the next tutorial, I'll give you my favorite. I'll show you again the way to connect to a virtual machine, and mostly I'll explain why to me this is the best. Alright, so check out all of them if you want, and in the next tutorial, let's find out my final recommendation. Amazon Web Services. There we go. So some of you might not be surprised, because indeed this is the most popular one, the most used one, and that's not only because it's Amazon, that's also because they have great advantages, which I'm going to explain and highlight in the next tutorial. But first, before we do this, I just would like to remind you where and how you can set up a virtual machine on AWS. I remind that I rather recommend a Linux virtual machine than a Windows virtual machine. You just need to go here to Product and then Amazon EC2. Amazon EC2 is exactly the virtual server on which you can be connected to a powerful computer far from you, but it's as if you had it in front of you because you can basically get into it and train your models inside. All right, so it's very simple to get started with Amazon EC2. You can actually click this link here, get started with Amazon EC2. But before this, I'd like to highlight the fact that in order to be connected to a server, you need to have an Amazon EC2 account. And of course, ultimately, when you use it permanently, it will be a paid account. And I'll talk about the prices soon. But the good news is that you can actually try Amazon EC2 for free. It's AWS free tier that includes 750 hours of Linux and Windows instances each month for 1 year. So you see, you can really experiment and see if you like it. But when you start, you can either click this link if you don't have any account on Amazon EC2. So make sure to get one free AWS account first, and then you can click this link, get started with Amazon EC2, and you will see they have an amazing guide that walk you through step by step to the process of connecting to a virtual server or a virtual machine. So here I already have an account. There we go. I think that's the one. All right. So here we are on AWS. The first thing you need to understand is that in order to connect to a virtual server or a virtual machine, which is called an Amazon EC2 instance, you need to create an instance first. And that's why here you have this option, Launch Instance. So you can just click it and you will have many virtual machines you can select. And you see that for each of them, it is specified if it is free tier eligible. And that's the one you must choose if you're still in the experimenting phase. Free tier eligible. So that's an example of one, but no worries if you see many of them. You might be wondering right now which one I should choose. Well, no worries, because the quick start guide, which is actually right here, getting started guide, will explain step by step which one you must choose to start. So they will tell you exactly the one, and then inside this one, they will guide you step by step. And you can see actually the steps here. Step 1, launch an instance. Step 2, connect to your instance, which is exactly what I was talking about, connecting to a virtual machine, a virtual server. And then step 3, you need to clean up your instance. And then you have some next steps. But let me show you here the main steps, the steps on how to get started with Amazon EC2 Linux instances. Perfect. So here you have an overview of how all this works. You have the prerequisite, of course, which is just setting up with Amazon EC2. Remember, on one of the previous pages, right after I clicked Amazon EC2, well, we had two links. First, getting started, and second, get the free tier in order to set up with Amazon EC2. Well, that's just a prerequisite. Make sure you set up with Amazon EC2. All right, and then you have the different steps. Step 1 is to launch an instance. And here, as you can see, it is explained in great details on how you should do it. First, you open the Amazon EC2 console. Then from the console dashboard, you will see launch instance. That's exactly what we did before. Remember, this launch instance button here, that's what you must do. And then you need to choose an Amazon machine image, AMI. So I'll show you this. If we click on launch instance here, well, these are Amazon machine images. And they tell you, as I said, the one you must click to get started with, which is this one, the HVM edition of the Amazon Linux AMI, and indeed it is marked as free tier eligible. So let's do this. HVM, this one, so that's the first one, HVM, and it is indeed free tier eligible. So we click on select, I guess that's what they say, and then on this next page, choose an instance type. You need to select the t2.micro type, so let's do this. You see, I'm just following step by step what they explain, and really we won't encounter any issue. Everything is well made on AWS. That's one of the reasons why it is my highest recommendation. There is no issue. It's very easy. And so there we go here. That's what we're asked to select. T2.micro, free tier eligible. That's the reason. So make sure to select this, but I think it's selected by default. And then they ask to click review and launch, if I'm not mistaken. Yes, that's right. Sub-step 5, review and launch. So let's do this, review and launch. All right, so we are connected to the right instance type, t2.micro. We're using one virtual CPUs with 1 GB of memory. No worries, the virtual machines you'll use for your machine learning models will be much more powerful, but here that's of course because it is the free tier eligible AMI to get started. All right, So then you need to click on launch. Let's check that it's the next step. Yes, indeed. And they give us more details on the review instance launch page. That's exactly this page here, review instance launch. Well, what we need to do is under security groups here, the wizard created and selected a security group for us. We can use this security group, or alternatively, we can select the security group which we created when getting up using the following steps. The steps are here, but we're going to use this selected security group here. That will do it. No need to get into much advanced details now. And then we just need to click on launch right here on this review instance launch page. Let's do this, launch. And now we have this window opening. And again, they tell us in great details what we have to do. No room for any issue. We just need to choose or create a key pair. So you will get your key pair of public key and private key when setting up your EC2 instance. Make sure to keep that somewhere. And here it will automatically select your key pair. And then you can just click launch instances. And there we go. We are connecting to our instances. Our instances are now launching. And then you can just follow the next steps. And then we can move on to step 2, connect to your instance. Alright, so I just wanted to guide you a little bit, do a little bit with you the steps on how to connect to an instance. Then you just need to follow the next steps. And remember, as a bonus of this course, I'll give you a nice and well-made practical PDF handbook on how to connect to your instance and get familiar with it. Well, first of all, it's because EC2 has great benefits. Recently, they changed their policy from per hour billing to per second billing. So basically what this means is that before, if you used it for 1 minute, well, you would pay it for an hour. And now if you use it for 1 minute, well, you will pay for 60 seconds. So the per second billing is a new great benefit of EC2. Then a second benefit is the flexibility. When using an EC2 instance, you can change basically the power of your virtual server. You can change the power of your virtual machine. Because indeed, you can change the memory. You can add some gigabytes if you need to. If your AI model or machinery model is requesting more resources, more computing resources. You can also change the number of vCPUs, and you can change some other, components of a virtual machine that are responsible for its power. Okay, so this flexibility is amazing because you don't have to start with a super powerful virtual machine if you're actually not sure of how compute intensive, how compute demanding your machine learning or AI model will be. And so, you can just start with a certain number of vCPUs, a certain amount of gigabytes, and then if it's not enough, thanks to this flexibility benefit from EC2, you can just increase the power by increasing the number of vCPUs or the amount of gigabytes or other components of the power. So that's a huge benefit, which makes it very practical. Alright, then another great benefit is actually the cost. Amazon for being the cheapest place where you can get some books or some products. Well, that's the same for cloud platforms. Getting a virtual machine to run your models is actually really cheap. I'll give you an example. If you connect to a virtual machine with 2 vCPUs and 4 gigabytes of memory, well, right now, at the time I'm speaking, it will cost you 5 cents per hour. So that's quite cheap, right? And 2 vCPUs and 4 gigabytes of memory is already quite powerful. You will probably need more, especially if you're doing some AI, but you can definitely do something with it. And that will be for 5 cents per hour. And then remember, thanks to its flexibility, you can increase the power. And so if you need to increase the power to, let's say, 4 vCPUs and 16 gigabytes, well, it will cost you around between 18 to 20 cents per hour, which is still very cheap. And here we have a much more powerful computer. And then eventually, a final benefit I must highlight are the EBS systems, Elastic Block Store systems, which are used by EC2 instances. And these EBS systems allow you to actually keep your data even if you're not using your EC2 instance. So it's not like, you have to keep your data in the server and pay for as long as you keep it. Because then, even if it's only a couple cents per hour, well, if you have to pay to keep your data, it could be costly. But thanks to this Elastic Block Store systems, you will not pay the regular price of the EC2 instance. but you will pay $10 per gigabyte per month. And so if you want to do that, there is something you must absolutely understand. It's the difference between stopping an instance and terminating an instance. So if you stop the instance, you will keep your data in the EBS system and you will pay $10 per gigabyte per month. But if you terminate your instance, well, you will pay nothing, but your data will be gone. There will no longer be your data on the instance you use connected to the EBS system. So make sure to get this. If you want to keep your data on the EBS system in case you need to retrain your machine learning model or your AI model, well, when you're not doing the training, make sure to stop the instance instead of terminating it. And if you stop the instance, you will just pay $10 per gigabyte per month and you will keep your data. And then, once you're absolutely done with the training, you won't do some further training, at least on this instance, well, you can terminate it, you will lose your data, the data on the EBS system will be removed, and you won't be paying anymore. So, make sure to get this. This is a great benefit, but it's of course important to be aware of this. However, and that will be my final recommendation or explanation on this Cloud Essential tool, if you're not sure of what to do between the two, just stopping your instance or terminating your instance, well, you have another solution. This solution is called S3, and this is one other Amazon Cloud product. So S3 is like taking a big snapshot of your data, which you can transfer later on to another EC2 instance with another EBS system. And therefore, it's not like it's totally removed. It will be removed from your current EBS system, but then you can transfer it, thanks to the snapshot, to another EBS. And what is the cost of doing that? Well, that's half the price of the previous solution. You know, keeping your data on the EBS system, which was 10 cents per gigabyte per month. Well, here, doing this alternative solution, it's going to be 5 cents per gigabyte per month, which could be a great solution for you. All right, so here we go. That's all the great benefits of AWS. That's my favorite. If you want to know about my second favorite, that would be Paperspace, because it is user-friendly, it is quite innovative, and it is mostly focused on machine learning and data science. So that's my second favorite, but it's great if you can check out all of them, because maybe you'll prefer one different from AWS or Paperspace. Again, that depends on your constraint, your goal, and the type of problem you're solving. So that's why in the previous tutorial, I insisted on giving you the top 5. So there we go, that's it for the cloud. In the next article, you'll find the bonus, which is a PDF report. It will help you even more set up your AWS instance. I just remind that you don't have to use the cloud. If you have a powerful computer, you can do it on your computer, especially if it has a GPU, and that allows you to run and train some powerful machine learning or AI models on your local computer. So you have a lot of options, but now at least thanks to this introductory course, you know the options and you can know which one suits best your situation. And on that note, I'll wish you a great data science journey. I hope you like this course. I hope this was useful for you, and I'm highly confident this will help you make a successful entrance in this fantastic world of data science.
And now let's quickly go through the topics that we covered off, just to reiterate the things that we discussed about each one. So throughout these tutorials, we got a feel for all of these components. We talked about statistics and the important elements of statistics that you need to get started. And it's not to say that you don't need to study any other statistics ever, but you can just look at the ones that we outlined, the 8 or the 3 core components, or 3 absolutely necessary components that will help you avoid costly mistakes. So the why behind this one is to help avoid mistakes that might be associated with statistical significance and other interpretations of results. And then as you go along in your career, you can always study a little bit of statistics here and there, pick up a few more concepts along the way, maybe even along this journey or after the 42 days. But you need to start off with those first 3 things at least that we mentioned. Then we had a look at the learn the data science process. So we talked about what it is and what are the 5 stages, and that gave us a good overview of what we'll be doing in data science, and that hopefully that helped see how all of these other components fit into the bigger picture of a data science process. So here we've got our own kind of process of learning, but the data science process is the process you'll be applying on pretty much any data science project that you'll be working on. And that's why it was important to cover it off early on. Then we touched on visualization, and that there's two types of visualization. There's a visualization for data mining and visualization for presentation. And here we allocate 10 days to this component because it is so powerful. As you can see from this this case study, like further down in the course in section 2, we had a case study of visualization for data mining, and we assessed customers of a bank and their likelihood to take up a product. So from that case study, you could see how powerful visualization can be already on its own. And that's why we allocate 10 days. So you have enough time to really get good at it and then be able to perform simple data science projects. And so here we actually have a checkpoint: attempt your first data science project. And that's exactly what was suggested, so that you basically in those 10 days find some time to attempt your first data science project and see how you go, and actually spend a couple of days or some time within a couple of days to perform that project to see what power visualization actually gives to you. Then we talked about databases, and that they're important in order to get access to more data, to get access to more information that you'll be able to analyze. And we're allocating 5 days here because it is quite important, and yet it's not that difficult to get grasp of one of the 4 main SQL type databases. And so you can pick one of your choosing, one of your liking. Maybe it's the one that is used at work, maybe it's the one that you prefer, and then you can just jump into it, learn how to use a database management system. That should probably take about 5 days. I think that's how long it took me to get into that world when I was just starting out. Of course, as with all of these, you will continue increasing your knowledge as you go ahead further down the track. But just to get started, 5 days should be enough. Then we talked about statistical learning, and Adlan gave you his 2 favorite books on the topic, and that was his way of starting into data science. It's an important step. However, we're allocating only 2 days to statistical learning because we don't want you to get carried away. It is very easy to get either too excited about the world of statistical learning or bogged down in it. And either extreme is not good because it is extreme. It's an extreme. The best way is to just pick at least, let's say, one type of algorithm that you want to really get to know quite well and spend those 2 days learning it. And just based on that one example, you'll understand what are the statistical learning concepts behind a machine learning algorithm. And then it'll be easier to pick up any other algorithm if you like. Or you can spend the 2 days just reading the overviews of different statistical learning approaches, and that will also be good. So basically those 2 days should be enough to get an intro into the subject, so that if you ever need to pick it up and dive further, you're already a bit more comfortable with this whole area. And then we dive into probably the biggest component, 12 days. So as you can see, that's out of all the days, 6, 10, 5, 2, 12, 5, and 2. We've got 12 days for machine learning. And that is because machine learning is the new data science, or a lot of people might consider that. Of course, there are other types of data science, as we could see with visualization. That's one of the reasons why we included this visualization for data mining, is because just to show you that even if you are completely not comfortable with machine learning or with coding or anything like that, you can still be successful with simply visualization techniques. But nevertheless, machine learning is indeed empowering data scientists all around the world. It is a very strong component in the data science skill set, and that's why we're allocating 12 days, so that you can go through and learn. You don't have to learn all of the machine learning. It's very broad. There's lots of algorithms. But if you learn even some of the basic classification, clustering, regression techniques, maybe some reinforcement learning, or some association rule learning. If you look at even the basics techniques in those 12 days, and you learn and you get to practice with 4 or 5 or 6 different algorithms, for instance, spending 2 days per algorithm, that should be a great overview of the subject. And in fact, in this course, we already gave you 2 algorithms. So Adlan walked you through 2 different algorithms in his practical examples with Python, and that hopefully showed you how easy it is to apply machine learning. And so in those 12 days, we suggest another checkpoint to attempt an advanced data science project. And now by this point, you already know some statistics, visualization, databases, statistical learning, and machine learning. And that should be sufficient to take on a more advanced data science project, something almost as at the level of Kaggle, or maybe at the level of Kaggle introductory type of projects. And of course, you can find other sources for projects as well. Then after that, after those 12 days, the next step is to learn more Python. And the reason behind this, the why behind this, is to speed up your data science, your application of data science. So you can apply machine learning in Python even without knowing Python. As you can see, you can just use templates or just select lines of codes. It's kind of like building blocks out of Lego. Whereas if you actually learn more Python, that should take approximately 5 days to get a good grasp of it and understand the basics of functions, variables, and things like that. If you learn that, then your application of machine learning will become much more seamless, and you will feel like a fish in the water when you're applying these machine learning techniques in Python or Spider or Jupyter Notebooks, or wherever you are applying these machine learning algorithms. And finally, at the end, we've allocated 2 days to deep learning, and that's to give you a general overview of what deep learning is. And in this course, we did showcase deep learning. We showcased deep learning with natural language processing with deep learning and computer vision with deep learning. So you can already see that it has potential. If you spend a couple more days on deep learning, even though you probably won't be ready to apply deep learning to challenges or problems, you'll at least know in which direction to think. And when those challenges come up, you'll be able to dig further and understand which deep learning algorithms apply and how to apply them on the job already. And your knowledge of machine learning will really help you out, because the whole concept of applying deep learning as just like as building blocks, as Lego bricks, is very similar. So you can just write a few lines of code and you can already have a convolutional neural network set up, or a artificial neural network set up just for the analysis of your problem. So there we go. That's how we get to the final stage, to day 42 in data science. And at day 42, you are ready. Congrats, you made it. If you get there, then you can already set up, go and start looking at Kaggle competitions, set up your own Upwork profile, and say that you're a starting data scientist and bid for jobs on Upwork. Or you can start approaching your first clients and see how you can help them there. So there we go. All in all, it takes 42 days. If you're excited about this journey, as excited as we are, then we challenge you to take it on and see where you can get with these steps. There are lots of materials. We offer lots of courses. If you're ever interested, we welcome you to check them out. But that's not to say that there aren't other materials. There's lots of other online courses that you can take, lots of books that you can read. You can watch YouTube videos. There's tons of materials online where you can find all of this knowledge, and hopefully this roadmap to becoming a data scientist will guide you, and you will know what to learn, what steps and checkpoints to take, and how much time to spend on each one. Try to practice some rigorous self-control so that you don't get carried away spending too much time, but also when you know that you only have, let's say, 5 days to study databases, then that should keep pushing you so that you don't let yourself stop and maybe take 2 or 3 weeks on the subject when you only need actually 5 days to cover it up.